All right. Good morning, everybody. Thanks for coming. My name is Robert Winterbottom. I'm a software engineer at Asymmetrik. And today we're going to talk about GraphQL, FHIR, and a little bit about JavaScript, but mostly GraphQL and FHIR. So I want to do a quick survey here. How many people have actually used GraphQL before? It's a very small amount. All right. Hopefully we'll change that today. All right. So I want to start off by talking a little bit about what GraphQL is, why I think it's a good alternative to REST. Then I want to talk a little bit about GraphQL and FHIR. They're obviously two different specs, and there's going to be some friction when they kind of combine. So I want to talk a little bit about that and some of the lessons we learned while trying to build GraphQL facade servers. And then at the end, I'm going to do a demo and hopefully have some time for some questions. All right, so what is GraphQL? So GraphQL was initially developed in 2012 by Nick Schrock, Dan Schaefer, and Lee Byron. There are a couple of Facebook engineers on the iOS apps and the Newsfeed API, and they wanted to add the Newsfeed to the iOS app. And one of the things that they were having problems with was getting data efficiently out of Facebook's data structures. So they built something they called Supergraph, and they played with that internally for a couple years. And then around 2015 was when they first publicly released the GraphQL specification. So when they built GraphQL, they weren't exactly sure what it was going to become at this point. They knew they wanted it to be language agnostic. They didn't want it to be coupled to any specific piece of technology. They also knew they wanted it to be database agnostic. So despite the name GraphQL and Graph Query Language, it doesn't just work on graph databases. This actually works on NoSQL, SQL, really any kind of database. And because it's language agnostic, there's a lot of interesting features that they're able to add. So some of the problems that GraphQL solved was it took a declarative approach to building APIs. And the way it does this is by allowing you to describe your data with its own type system. So in JavaScript, we have numbers, we have strings, but we don't really have a whole lot of complex data types. And because GraphQL didn't want to be limited to that and tied to any specific syntax, they came up with their own type system. So they have GraphQL ints, floats, Boolean strings, all your common stuff. They have lists, non-nulls, unions, interfaces, all that good stuff. But they also have the ability to define your own custom scalar types. And this is really interesting for FHIR because FHIR has types defined like positive int or date time, which really might be a string or might just be a number that has some rules that you need to apply to it. So in GraphQL, instead of trying to map those to whatever language you're using, you can actually define a scalar and say, I want to have a date time type, it's going to be a string, and then it needs to satisfy this regular expression. Or I want to have a positive int, it needs to be a type number, and it's going to satisfy that it's greater than or equal to 0. And because GraphQL has this type system, it can do a lot of validation and type coercion for you. So when I say validation, it's not in the sense of like full validation that you might expect with FHIR, where it's validating terminologies and referential integrity. It's really just doing structural validation. So it'll make sure that the structure's correct, the data types are correct, and that's basically it. So anything past that, you need to implement yourself. But the type coercion is also really nice. So if you define an input as an array of strings and you give it strings, GraphQL will attempt to coerce it to an array of strings or to whatever data type you defined before it ends up rejecting it and throwing errors. So the next thing I want to talk about with GraphQL is kind of getting exactly what you asked for. So because of this, you know the data types, but when you look at a GraphQL query, it's a little bit different, but you only get the information you ask for. So on the left-hand side, I have an example query, and on the right side is an example response. So if we take a look at this query real quick, the blue text that you see is the schema, so that's patient in this case. In the parentheses, you see some arguments that we're providing. So we have ID equals 1. And then if you look at what follows that, it's kind of looking like JSON, but it's missing values and it's missing commas and a couple other things. But this is really just the syntax for asking for outfields. So in this particular case, if you look at the response on the right, it's essentially the same thing that's on the left, but it just fills the values in. And it doesn't give you anything else. And I think this is actually a really important feature because if you're on a client-side development and you look at this, you know exactly what data is coming in, and you're also not overfetching data. So if we took let's say like an example mobile application. Let's say you're a provider, you've logged in with Smart on FHIR, and you want to see a list of your patients. So you're going to render a table view. Inside that table view, you just have patient names. So with GraphQL, you can just ask for a patient name, and that's all you get back. You're not really wasting bandwidth. If we took a look at an example REST response, you might see something like this. And this is actually truncated, so you see a lot of ellipsis in there, but you end up getting all this information back. So if you're rendering a table view, and all you need is names, you're really wasting a lot of bandwidth because you're asking for all this data that you don't necessarily need. And you're also exposing information that you may not need to expose. So having queries built this way, it's actually really efficient. And this has kind of another feature that it's really good for clients, because a lot of the client libraries like Relay Modern and Apollo Client allow you to collocate queries. So if you're building this table view, right next to your rendering logic for the table view, you could put a query fragment, so name given, and that's it. And then the client-side libraries will actually aggregate these together and then figure out an efficient way to make those queries to the server. So now you have your data requirements and your rendering logic side by side. So this makes maintaining applications on the front end really easy. Another thing that you'll see with GraphQL is they do try to make a lot of efficiencies. So another one of the big ones is doing multiple resources in one request. So here's kind of a simple example of querying a patient, an observation, and a medication request. Typically, if you're doing this with REST, you end up making 3 HTTP calls, and you have to hit the 3 different endpoints. GraphQL gives you this nice way to actually do this all at once, saving you a bunch of HTTP requests. So in this example, you might not see a big difference, but if you imagine that you're querying 15 to 20 different endpoints, having to do 15 to 20 HTTP calls on a mobile device isn't going to be the most efficient. And they can only do so many in parallel, so what ends up happening is you might do 4 or 5, and then once some of those are fulfilled, it'll start running the next ones. With GraphQL, it's just one single request. And they'll actually format your data back so that when you get the response, similar to what we saw earlier, you'll have your top-level patient schema, and then you'll have the response from that query. Then you'll have your top-level observation, and then you'll have the results from that query. So it's really nice. It doesn't waste a lot of space. And it's just a convenient way to kind of think about your queries. One thing to be aware of, though, with this is if you're doing 15 HTTP calls and you have an error, it's pretty easy to deal with because one call fails, 14 succeed. It's really easy to figure where that is. But with GraphQL, it's just one request. So how do you handle that? Like, what's the preferred way in GraphQL? So GraphQL implemented partial error handling. This is a really nice feature. So let's take an example of I'm making a request. I've already authenticated. I'm going to request a patient and an observation at the same time. So my scopes say that I'm allowed to read patients, but they say I can't read observations. So if I make that request to a GraphQL server, one thing you can do is in your resolvers, I can return patient data because the user has permission to view patients, but they don't have permission to see observations, so I just return an error. And that's really all you have to do to implement this. And then GraphQL will handle the rest. And then what you see at the top is actually an array of errors that were encountered during your request. So in this particular case, it's saying I don't have sufficient scope for read access on an observation. This is really nice to do, but they also go further with this, so you don't just do this on the schema level, you can actually go to the field level. So if I just kind of make up like a fake example, let's say for some reason a user can see a patient ID, but they can't see a patient name. So you can actually go into the patient name field and add a resolver there. You can give them back a patient ID, but then give them an error that says, hey, you don't have access to read the patient name. So you can actually do this partial error handling all the way down your response tree, which is really nice. Another really neat feature that GraphQL has is introspection. So you can query these endpoints and get a lot of information about the server. And because of this, you get some really neat things. So one of my favorite tools to use with GraphQL is the Graphical Explorer. And this comes with our implementation. It's really easy to use. You just turn on a Boolean, and it'll automatically generate this for you. And what this essentially does is once you start your server, you get this endpoint, and it does introspection on your server. It finds out your server capabilities. So on the right-hand side, you'll actually see a documentation explorer, and it'll list out all your operations, so queries, mutations, subscriptions, that kind of stuff. You can then dig into these, so it's all interactive. You can click on query, click mutation, see what schemas they support inside of there. You can see what input arguments each schema has, the return types, descriptions, all that good stuff. You can even search through it really easily. The left side here is the query explorer. So this is kind of like an IDE. You get code completion. You get a lot of nice features, the command click to jump to the documentation. You can just write all your queries in here and start testing stuff. And then you can run your queries, and then in the middle panel, you'll actually just get your results back. So this is really convenient to use when you're kind of exploring and learning GraphQL, because you can just start writing queries and seeing how they work and how they behave. And from a client-side perspective, the introspection capability is really nice too, because again, with like Relay Modern and Apollo Client, they typically need a GraphQL schema to work. A lot of them compile the schema ahead of time and generate artifacts they need to work on clients and make efficient queries. So writing that by hand would suck, especially if you support all of STU3, which is a lot of resources. You might have like a 1,000-line long schema file. But with the introspection API, you can write maybe 15, 20 lines of code. You run a single query, and then it just writes out these schema files for you. So it's really easy to generate a lot of this stuff. And it's kind of like there's not really an official capability statement for GraphQL yet. That's one of the to-do things, but the introspection is probably the closest you'll get to it because you'll describe your entire endpoint and what you have. So the next thing I want to talk about is what a query looks like from start to finish. This is very much like REST, but there's a lot of extra things that happen. So I've kind of made this quick diagram to go through it, and I want to walk through that now. So on the left side, we have a query, and this is just like the query we saw earlier. We have a patient query coming in, and the first thing GraphQL is going to do is it's going to look at the query, and it's going to parse it into an AST. And after it does that, it's going to look at what you're asking for. So if you're asking for a patient schema, it's going to see if you have a schema declared that matches what you're asking for. If there's no schema defined for patient, then it's going to return an error. If it has one, then it goes to the next step. So after it looks at that, it's going to look at the arguments you provided for your query. If the arguments aren't valid or you have bad types or something like that, GraphQL will catch that and throw an error. Otherwise, it kind of goes on to the next step. The next thing it's going to look at is your return field. So if you're asking for data that doesn't exist on a patient, GraphQL is going to say, I don't know how to handle that, and it's going to return an error. But if it's valid, it's going to finally go to your resolver. And up until now, everything's been declarative and fairly easy to write, but when you get to the resolvers, that's where you end up writing the majority of your logic. So in a patient resolver, they're going to give us a map that contains the arguments. They're going to give us server context, a couple other things, but this is where you need to connect to your database. You need to take the GraphQL arguments and generate database queries, run your queries, and then format your results if you need to format them. But that's really where all your logic happens. So, and again, if any errors happen, resolvers are pretty flexible. So if you've done JavaScript before, you just return the data if you're doing a synchronous query, or you do promise or an array of promises, and the resolvers just work either way. So if all that goes well, then the data finally comes back, and it goes back to the client with the 200 response, and then you get that errors data response that you typically see with GraphQL. And this makes it really nice because you can, the way we build our servers is we're actually just looking at structure definitions, and then we generate all these schemas programmatically. So we don't have to write code for these schemas, and then we just write kind of an empty resolver file. And then when we want to implement these endpoints, we just go to that resolver file and start writing queries. So it makes it really fast for us from a development perspective. So the next thing I want to talk about is GraphQL and FHIR together. So currently, GraphQL and FHIR is not yet a formal standard. I think the goal is to have it ready by R4. So hopefully when R4 is released, GraphQL will be kind of finalized. It's still in the early phases, so I mentioned that we don't have like an official documentation on what a capability statement looks like. And if you're not doing a standalone GraphQL server, if you're adding GraphQL as like a feature to your current REST server, then how does your capability statement describe what your GraphQL server can do? It's not really defined yet, so that's something we need to work on. There's also patch, batch, mutations. Some of that stuff is still listed as to-dos in the documentation, so I think from a community perspective, we can work together and try to figure out how those pieces should work. The nice thing with GraphQL is that we're using Express GraphQL, which is basically middleware. So it's really not imposing on our architecture or on our stack, so you can still do all your validation and all your other things that you want to do on your server outside of GraphQL. It's really easy to implement. But there are some key differences when you're working with GraphQL and FHIR because, as I mentioned, they are both specifications and things don't always work nicely. Usually they do, but sometimes they don't. So first thing I want to look at is data. So, and it'll say this in the specification. The data kind of looks like FHIR, but it's not exactly FHIR. And what that means is GraphQL specification defines that if you have a successful query, it should be a 200 response. You should have a top-level errors field and then a top-level data field. And inside data, you'll see the name of the schemas that you're querying. So if you're querying a patient list or an observation, you'll see that field here. And once you look into that field, that's when you finally see your FHIR data, essentially. So everything inside patient, in this case, would actually be a patient resource. But it's not nested at the top level. The response doesn't exactly look like FHIR, so there's some slight differences just to be aware of. There's another place this happens too, and that is with errors. So errors in GraphQL have their own spec again, and it's still a successful request, so they want you to return a 200 response. But you always have a errors object at the top level, and it's an array of objects, so every error you encounter has its own object in here. And each error essentially has to have a message property. And there's a couple other properties, but they're very clear that you have to have a message defined. If we look at errors in FHIR, they're typically operation outcomes. They're often associated with various HTTP status codes, and you'll get a response that looks similar to this. So trying to figure out how to make these two work together, they're obviously two different things. You kind of have to compromise. So we talked with Graham in the past, and we kind of came up with the interesting idea of using GraphQL's extension properties. So in an error in GraphQL, it has extensions. The only contract you have to really adhere to with this is that it's a map. So as long as you have a map in there, it's fine. So in our case, we're adding a resource property, and inside that, we are embedding our operation outcome. And then I've truncated it here, but typically we'll take whatever message you have in diagnostics, and then we'll bubble that up to the messages so we satisfy GraphQL's requirements, and we still have an operation outcome available. That way, FHIR users can still get access to FHIR resources. So the next thing I wanted to talk about was bundles. So bundles are a little bit different in GraphQL. And if we look at structure definitions, inside of a bundle you have an entry, and then you have or an array of entries which contain a resource. And it says a resource is essentially just a type resource. So any resource that you support could potentially be inside your bundle. GraphQL is very specific on its types, so if you say that, you can't ask for patient fields, you can't ask for observation fields, you could only ask for resource-specific fields. So what you end up doing in GraphQL is you have to create a sort of a union, which is a resource list. And you see this if you've seen JSON schemas before. Essentially, every resource that our server supports, we list that as one of the potential properties in our union. And then when queries come in, you can look at the resource type and then use that to try to figure out which resource you're actually looking at. And then it'll apply the actual resource type to it and do the validation that way. But because of this, querying GraphQL unions is kind of weird and it's kind of funky. So I want to show you guys what that looks like. And it gets a little bit verbose. So here's an example where we're querying a patient list, and a patient list returns a bundle. It could be one of many resources, but because GraphQL is very specific on what's coming back, you can't just generically say I want an ID. And it doesn't make sense in the case of an ID because ID obviously applies to every resource, but if you think about gender, it does make a little bit more sense because observations and medications don't have genders. So if you ask for gender, it'd be kind of weird because not everybody really has that field. So you have to use these kind of conditional fragment syntax, which is this ... on, and then essentially your schema. So in this particular case, we're doing a query. We're really only interested in patient and observation resources, so we'll do this ellipsis, and then we'll say I want these fields from a patient and then these fields from an observation. And while this can get really verbose, it is actually fairly nice if you're developing client-side applications because you can take a look at the query and you don't have to like log all your responses coming back from a server. You can just look at the query and know exactly what data field you're getting for what type. So if you're rendering that table view for a patient, it's really easy to just say, okay, let me look at the patient. I see I have ID. I'm missing name, so I'll add name, and then I get my names back. So it's really easy to work with on a client-side perspective. The other side of this is writing. So GraphQL doesn't support unions or interfaces and mutations, and because of that, we can't have that same capability on the right side. So we've been kind of playing around with a couple different options for this at Asymmetrik, and we're still trying to figure out which one we like the most. This was one of the ones that was suggested by the community, but we didn't like this. So what ends up happening here is you can't say a resource and then give it any generic type of resource. You actually need to be specific. So you might say patient resource, observation resource, or whatever type of resource it is. But like I said, we didn't like this because now you have essentially a different structure for bundles when it's coming in or going out. And we'd like to keep that the same, or at least as close as possible to the same. So another option to that is essentially using strings. So when we receive a bundle and we're trying to write like a transaction, we look at the resource, it's a JSON string. You just call JSON parse on it, look at the resource type, then try to see, it's almost like we're doing similar to what GraphQL does. We look at that resource type, then we go see if we have a schema defined for that type. If we do, we load that schema, and then we can use that to validate, or at least do a structural validation on the resource. If we don't, then we know we have an error. And then once we validate against that, we get all the same validation benefits you would get with normal GraphQL schemas. But it's just a little bit more work to do it this way. We're also open to suggestions, so hopefully some of you guys will check out the server later today. We do have a demo that we'd love you to try. So if you find a better way or an alternative, we're definitely open to hear about it. Yeah, so on that note, let's do a demo and hope it works. All right, so find my cursor real quick. All right, this is actually kind of weird trying to do this. All right, so I'm going to bring a couple windows over here for you real quick. All right, so as I said, we have a tutorial available. You can definitely download it. What I'm going to demo now is really just the second half of that tutorial, so I'm not going to do the full thing. But it does include, hold on one sec. See if we can get this thing to stop glitching.
Doesn't like that white window. You can it on the screen.
Oh, it doesn't?
I don't know why.
Maybe I need to mirror displays. Hold on one sec. Hold on.
Show the other window a little bit back.
Yeah, that's what I'm... All right, maybe I just need to flip back and forth every couple of seconds. Keep it happy. All right, let's see if I can... No, doesn't like terminal. All right, we'll be really quick with terminal. So, essentially at this point, I have the project locally. I've already installed my dependencies. I've got Node.js set up, all that good stuff. So we're going to go into the case of writing a resolver, executing a query, and then seeing what the results look like. So I'm going to bear with me for one sec while this thing glitches. So I'm going to start a development script. We're just using NodeMon. Essentially, it does reloads anytime you change a file. No? Back to here. This is awesome. And it's still happy. All right. Maybe, no. Yeah. Fantastic. I could try. Just make this my background. God, it really doesn't like this for some reason. All right. That's moderately annoying. All right. I'm going to try something here. I'm going to bring this. Oh, God, now it's going crazy. All right. All right, so I'm going to try to write the query, unfortunately, on this side and drag it over really quick, and hopefully we can see it before it starts glitching out on us. If you come find me after this, I'll be sitting at the table over there. I'd love to show you this again when it's not going crazy. The query I'm going to show is essentially very similar to what we saw earlier, so give me one sec real quick while I... No, dang it. Yeah, let's try that. Is that happy with my editor? Seems like it. Okay. All right. So this is the query I'm writing in. Let me find my cursor. The query I'm writing in GraphQL essentially looks like this. So we're going to run a patient query. We're going to ask for ID. We're going to ask for name, and then inside name, we're going to ask for the given property. So if I were to run this query, let's go back to, this is going to be really fun here. I end up with something that looks like this. And as I mentioned, we're generating a lot of this code. So right now our resolvers return empty objects, and you can actually see the resolver code right above. So that's why we're seeing null, is because I don't have a patient to return. So part of the tutorial is going to have us go to hl7.org's website and grab the patient example JSON, which is, actually it's right over here. So I already downloaded this. This is just a simple JSON file, and I'm going to use this to kind of mock out a backend. So instead of actually connecting to a database right now, we're just going to grab this file and then return the JSON so you can kind of see the full workflow. In a real world, obviously, you'll do your database queries here, but just in the interest of time, we're going to do something simple. So if we go back to our resolver, all right, so the first thing I want to do is create a patient object, and we're going to return that patient. We're going to grab an ID, so just to make it a little bit more dynamic and less completely boring, we're going to send in an ID argument to our patient query. So we're going to grab that ID from the args. You can see that we have a couple other things here, like root, context, info. Inside context, we're actually providing some things, such as the version that you're on. We do support DST2, ST3, and are in the process of supporting R4. So it'll tell you the version, you'll get your original request and response that you get with all Express controllers. And then our server class has loggers and a couple other nice things attached to it that you can use. So we're going to do a simple synchronous try catch here. And what ends up happening here is the first thing I'm going to do is just try to acquire this file. We're going to load it based off of the ID. So if I query for ID example, it should grab patient example JSON. If we have an error, we're going to log the error. GraphQL does have a different error syntax if you use extensions. It's not just like a normal JavaScript error. So we've created some utilities. The first one is not found, so it's going to wrap the error in an operation outcome, and then the second one is going to format it for GraphQL. The way we set this up, you can just return errors anywhere you want, but if you don't format it into an operation outcome, then we're not going to know exactly what caused the error, so we're just most likely going to wrap it as an internal server error. But if you want to have a little bit more control over it, you can do that as well. So we're going to go ahead and do this, save it, wait for server to restart. Oh, unexpected token. Hold on. I left my query sitting in there. All right, good. So I'm going to rerun that same query on my side. Just give me 1 sec. I'll paste the results back into my editor again. All right, and you can actually see the logs already popping up saying it's got an unexpected GraphQL error. And the reason is because I'm not giving it a query argument right now. So this is kind of what we saw earlier. So we have data patient null. It wasn't able to actually find my patient. And then up top we have an array of errors. You can see it's telling us it happened at the patient schema, and it's basically telling me it can't find model. So it's just catching that JavaScript error. So if we change our query, all right, so my query now looks something like this. So I'm now giving it an ID. So patient schema ID is example, and I'm asking for the same bit of information. So if we go ahead and run that query. All right, my results now look like this. So I have data, I have patient, I have an ID as an example, and then I have a name, which is actually an array. So it's going to give me an array of objects, and inside of that I have the given, and then that's where we see Peter James, Jim, and Peter James. And that's pretty much it. It's that easy to do GraphQL queries. So if we wanted to add more fields, for example, we could just add them directly here. So if you imagine that you're a client-side developer and you need more information, you need maybe gender, birth date, a couple other things, it's really easy. You just add those here. Didn't spell that right? Not even close, wow. Yeah, that looks good. All right, so if we take this query, we're going to rerun this. And now we get something back like this. So again, it looks exactly like what we just had, except now at the bottom we have gender and birth date. And that's it. It's pretty simple. So we do have all of our code open source on GitHub. I would show it to you, but this thing is going to freak out if I bring Chrome over. So if you go to github.com/asymmetrik/GraphQL FHIR, you can actually... Okay, didn't copy it. Hold on 1 sec. There we go. You can check out our server. It's written in Node.js, really easy to get started. And then we also have a tutorial that you can download. So give it a shot. Let me know what you think. And I'd love to hear some feedback from you guys. And yeah, that's it. Thank you. I think we still have some time for questions. Any questions? Oh. I guess back here.
Yeah, sorry, maybe I missed this, but you said GraphQL has its own data types, has these schemas and so on. So what's the relation between those and the standard JSON schema? Are they the same, or is one a subset of the other, or what is? So
the question was, how do they relate to the JSON schema types? GraphQL's type system is completely independent of any language specifics, so there's no relation to JSON schema, to JavaScript, to PHP, Python, or anything really. If you go to the GraphQL website, they'll have documentation about all the types, and then you can actually even look into their code if you want to see what they're using to enforce them, but they're really their own description. So A good example is GraphQL int. If you use that, JavaScript just has numbers, so you can give them these massive numbers, but if you try to do that with GraphQL int, it'll actually properly enforce that the number is not too large. So in that case, you'd have to use a float or something different. All right, good question.
What happens with operations?
You mean like queries, mutations, and...
Like value set expand or that sort of thing?
Yeah, so that's another thing. We don't really have a good implementation guide for GraphQL and FHIR just yet, so that's one of the things that I'd like to kind of work on with people in the community. Maybe we can start developing some of these things. There are some areas that still aren't supported, at least in our example. Our example is pretty simple, just to get people up and playing with it really quickly. That's something that we're looking at, and then like modifiers as well as another one. So like greater than and those kinds of things that you would put on dates or numbers we're also looking at as well. But yeah, I think that there's still some work to do for GraphQL before it's completely ready.
Hi, I actually have two questions. You said you take structure definitions and you generate GraphQL schemas from them.
Yep.
Is that open source or is that proprietary?
So at the moment it's proprietary because we tried to do it really quickly, so it's a little bit ugly, but it will be open source eventually. Yeah. Oh, I think a mic just died.
Do you have a time frame on that? Okay.
Maybe a month or two. We had a lot of things that we were trying to get ready for the conference, and we're actually pulling a lot of the logic out of our servers and trying to open source a lot of the various pieces. This is one of the ones that we want to open source, so maybe in a month or two we'll actually have that figured out.
Okay,
Hopefully
thanks.
sooner, though.
Second question is, I have a lot of client engineers who are very interested in using GraphQL. We have they use GraphQL for some other stuff right now, but we also have to, or we're also considering building our FHIR server, using FHIR. So ideally, you have GraphQL all the way up and down, so that you don't do unnecessary fetches against your data store.
Yep.
But would you say it's a reasonable implementation to put a GraphQL server over a regular REST FHIR server? I mean, just to avoid the bandwidth going to the client?
You can, yeah. So we one of the first things that we did with GraphQL was we wrapped Elasticsearch and we wrapped a couple other sources, and one of them was just a standard REST API for the exact same reason. We already had all of our developers hitting this one endpoint, and we didn't want to have them doing multiple domains, so just to be more efficient, the client can make that one request, and then we let the server deal with that.
Okay, great, thanks.
Yep.
Great presentation, thank you. I see for GraphQL seems to be the most value it brings is really to reduce these queries, so the amount of data you need to transfer.
Mm-hmm.
Did you have a look at the summary, which is a query parameter in FHIR that, well, that's what I'm using.
Yeah, so we haven't really used that specifically, but you do see that in a lot of REST APIs where you can specify outfields to try to limit that. And if you use that, you'll get a lot of the same benefits. GraphQL's default is you have to declare what you're asking for. So if you wanted to ask for all the fields, it's a little bit annoying, but you do have to enumerate all those fields in your query. Whereas I think REST is typically it's the reverse. Not always, but typically REST gives you everything unless you use some sort of field to say, hey, filter these fields out and remove these. But yeah, you'll get a lot of the same benefits that way.
Thank you.
In the FHIR model, you have relationships, like on an observation, you have a subject. Are these relationships also in the graph model, in GraphQL?
I'm sorry, what was you said in observations we have?
On observation, you have, for instance, a subject.
Socket?
Subject.
Oh, subject. Yeah, so we're not, like I said, we're not doing too much validation on that. So right now it's just treated and it's just kind of passed in.
The validation, but the relationship, it's a relationship to another resource.
Yeah,
So is that also, could you fetch a set of observations and then the given name of the subject, for instance?
Yeah, so in your resolvers, we still have to figure out like how we want to handle includes and those kinds of things if it's not something you wanted to keep in by default. But if you wanted to get that information back, you could. It's essentially you just look in your resolver when the data is coming back and look at all the references and then just resolve all the references that way. You could invoke other resolvers or you could just do it from whichever one you're currently in. But yeah, you could do that if you wanted to.
So I work with Rob, so this is more of a comment than a question. But one of the key features of GraphQL that sort of differentiates it a little bit from FHIR right now is that there is an ecosystem of tools that can actually support GraphQL queries, so on both the back end and the front end. So by using that, you actually can then use things like Apollo client that are already out there and exist.
Yep, good point.
So I just want to make a couple of comments. First of all, I wrote a GraphQL implementation for Happy, although James hasn't yet integrated it into Happy inside the search engine. So you guys could lean on James to actually do the integration of all the code that I wrote for him to do that. The other thing is there is a page in the spec about GraphQL which does talk about how to walk across references, either forward or reverse references, to bring them into the package, and that's where you start to really differentiate from using summary, because you can, dance a deep graph and get back a really simple, shallow thing back. And also that page talks about how to use GraphQL with operations.
Yep. Yeah, I would definitely encourage you guys to check out the spec. If you just do GraphQL FHIR, it should be one of the first links that comes up in a Google query.
So there's some initiatives that say that GraphQL is like the REST 2.0. Do you think it should be a core transport of FHIR to support GraphQL as native?
That's a good question. So GraphQL did recently announce the GraphQL Foundation, and they partnered with Linux Foundation. You're seeing a lot more support coming out with that now. That'd probably be a better question for Graham, but I personally like using GraphQL. I do really enjoy it from both the server perspective of developing GraphQL servers and then from a client perspective of consuming them. I think it's really nice to use. So I definitely want to see it more popular than it is now. So, when I asked everybody in the beginning and saw a couple hands, hopefully by the end of today that changes and a couple more of you have had a chance to play with it and test it out.
Thank you for talk and for your open source projects. How do you handle extensions in GraphQL?
So extensions, I think I stopped sharing. So like I said, we're mostly doing structural validation. So we have, do you mean if you have a birth date and then you have the underscore birth date field, or actual extensions?
I mean, yes. In GraphQL, you enumerate the elements, attributes, and
Yep.
you can enumerate what specific extension I want to get in the future.
Oh, yeah. So generally extensions, at least from what we have, are following a fairly specific structure. So you would just ask for those particular fields, and then it would just bring back whatever extensions it has. If you're doing custom extensions, then it might need to be run through one of our tools ahead of time. So as I mentioned with the resource generator, we're kind of doing this statically. We'll just run this script locally. It'll spit out a whole bunch of GraphQL schemas, and then we upload them. So if you have some custom profiles or custom extensions or things, once that tool's open source, you could run them through that, and then you'd get support for those as well.
I can say I need this couple of extensions from this resource. Is it enough? Expressive power of GraphQL to say this. I mean, filter the collection of extensions.
Yeah, I think so. If you want to come grab me afterwards and go through a little bit more detail, I'm not sure I completely understand what you're asking, but yeah, I think we could probably support anything in GraphQL once we just figure out how we want to do it. All right. Thanks, everybody. If you have questions, I'll be over there later.
You asked, you suggested I could comment. So a couple of things. We do actually talk about extensions in the GraphQL page.
Okay.
I would love to see every server out there support GraphQL. I think that you combine with the rest, it's not a either or.
Yep.
You have a RESTful interface and then you do some things with GraphQL. It's a very powerful combination, and it's a real frustration for a lot of clients that they can't do exactly that.
Right.
And just say, actually, here, I just want this package, give it to me as a package. And my server supports it, and Robert's server supports it. That's useless. So I'd really love to see every single server provide a GraphQL support as part of a standard RESTful interface. But no, we're not going to make that a conformance requirement. It should be a social pressure from the community. So go and talk to your server provider and go, can you guys just do this? Thank you.
Yeah. Yeah, that's a good point, actually. So our server that we have is just a standalone GraphQL, and it's just meant to be a really quick way to get in there and kind of explore stuff. But yeah, I'd agree. It'd be really nice to actually have a lot of those side by side. Cool. All right, thanks everybody.